Can you see the screen? Can you see the slides?
Yes.
Yes, doctor.
Okay, that's fine. So let's start. Okay, today I'm planning to talk about these outlines, a brief introduction about the questionnaire validity and definition of the validity and reliability and types of the validity and reliability, and also some more details about the what do you call it, the different type of measurements regarding to checking the questionnaire validity and reliability. But before starting, let's start with this question. What is the research? As you know better than me, the research is a systematic investigation and a study the materials and resources in order to establish the facts and reach to the conclusion. And this process started always by gathering the data, and this data can be processed with some techniques and methods in order to generate the information and establish the facts. Of course, at the end, we can improve and advancement the body of knowledge. This slide also shows the the classical the steps for any kind of research. As you can see here, the step 3 is to define the variable and instrument. So it is very important to know how you want to measure the outcomes and the variable of interest in any research. The questionnaire actually, this talk actually we focus mainly on the questionnaire. You know, the questionnaire structure always consists of items in terms of, let me to mute my phone, sorry. Okay, the questionnaire is a method or tools to collect the data from the target population, and of course that is tools or instruments should be validated and reliable before starting data collection. Otherwise, the information that you will generate at the end of a story will be biased and cannot be reliable. This is very important for any type of research, that we make sure that our research instrument is a valid and reliable tools to be in safe side in terms of generalizing our finding at the end of the story. Of course, as you can see in this slide, initially we have to identify the goal of our instrumental research tools and what kind of information actually you are going to collect through the questionnaire and instrument. This all should be tallied with your main objective in the research. Achieving the valid information depends on some question that you may answer to these questions prior to start any research. You can ask yourself what is the purpose of questions, ask the concrete questions. The time also is another critical factors in asking the questions in the research questionnaire. The language is very important, especially for those population that they have different language. For example, in Malaysia, the dominant language is Malay. So, of course, if you want to do and collect data from the population, you need to make sure that the respondents are able to understand the questions. This is very critical factors. Just to share with you some of my experience, we did a study a long time ago with one of my students, and unfortunately the students used the original questionnaire, which was based on English. And when we analyzed the data, we found something contradictory with the literature. And that was due to what they call it, misunderstanding of the questions, because the target population were not educated people, and they suffered from the poor English language. That's why they would not be able to answer correctly to all the research items. So this is very important, the language of the instrument. When you design a questionnaire, of course, you need to use the complete sentence and also avoid to use the abbreviation, or also avoid long form of the questions, because sometimes you have to make everything simple and easy to understand. Okay, what is the validity and reliability? Can you unmute your microphone and answer to my question? What do you think? What is the validity and what is the reliability? That's a problem for the online session always. I love to teach face-to-face to be more interactive during the teaching process, but the online sometimes is difficult. Okay, please share your idea about the validity and reliability. Can you hear me? Hello?
Yes.
Okay. So would you please share your understanding from the validity and reliability? What does it mean? What does it mean, the validity?
Hello.
Yes, please.
Reliability is consistency of instrument, and validity is accuracy of the instrument.
Fine. Anything more? What does it mean, validity? When you design an instrument or questionnaire, what does it mean? The questionnaire must be validated. What does it mean? A valid instrument. The validity refers to ability to measure the variable of interest. Suppose that if I want to measure the body temperature, so if I want to measure the body temperature, which of these instruments can be used? Can I use the mobile phone? Can I use the ruler or scale? Of course, no. Only these two instruments can be used to measure the body temperature. So this means the validity. So it means the instruments able to measure the variable of interest, the outcome. So the outcome in this study is body temperature, and I'm able to measure the body temperature only using these two devices, correct?
Yes.
Thank you. Okay. And what does it mean, reliability?
Hello?
Yes, I can hear you, please.
Yes, I think reliability is about how the instrument is able to give a dependable measures each time we use it. Same measure, consistent measure.
Same measure. Great, consistency. This is the key word. So look at here. For example, I use this device 7 times on the same person. As you can see here, the reading are very close to each other, correct? 37.2, 37.2, 37.1. So discrepancy is very low among the reading on same subject, correct? So means the readings are reliable. The readings for the body temperature 7 times are consistent. While in this reading, the same person, but we use different instrument, different the measurement for the body temperature, the thermometers. So as you can see here, in each reading, we have different numbers, correct? So it indicates that this instrument is not consistent, despite the subject, the person is the same person, and within a short time, but we have different readings, and it indicates that this instrument is not reliable. So the reliability means consistency of measurement. So as you can see here, this is one of the typical famous graph to show the concept of the validity and reliability. The last one, as you can see here, the measurement was reliable and valid. Why? Because the readings are close to each other, and also it's targeted to the main outcome. So this is, for example, in this figure, you can see that the results or the readings are reliable but not valid because it's a bit far from the target. So we have different type of, what do you call it, situation. Of course, always we look for the reliable and valid instrument. In research methodology, we have two types of validity. Let's start with validity and then we move to the reliability. We have two types of validity, logical and statistical. Of course, we will explain in details for the statistical validity, but we need to also look at the logical validity. Have you heard about the pretest? And pilot study? What is the difference between pretest and pilot study? Hello? What exactly we do in the pretest and what we do in pilot study? What is the difference between these two different steps in any research?
Hi, Doctor.
Yes, I can hear you, please.
I think pretest is about you have a initial testing on certain component of your entire test, while the pilot test is you're using the whole questionnaire on a smaller sample. Is that right?
Almost, yes, correct. Anything else? Okay. The pretest referred to in terms of the validity, the pretest is referred to the logical validity. So before at the initial step of any research, we need to make sure that our questionnaire is logically validated in terms of the face and content. So these are two types of validity. Face and content validity can be categorized under logical. For the logical validity, always we concentrate on data collection among experts. So means prior to collect data from any sample from the population, from the target population, we need to make sure that our questionnaire, our instrument has adequate validity in terms of content and face validity. And that can be done only through expert validation. So remember, the pretest refer to the logical validity. So means initially, once you prepare the first draft of instrument, then you can expose this instrument to a group of experts. Experts can be academic experts, for example, the university professor, lecturers, academicians, and also the experts in that particular area. Suppose that if you concentrate on waste management, for example, and you design a questionnaire to collect data for waste management practices among the industries. So beside the academicians that can be joined to the panel of experts, better to approach some experts in the field. You can go to the industries, and some of the waste management, managers in some practices also can join to this evaluation. This evaluation is 100% is qualitative. So qualitatively, you will evaluate. You have to evaluate the content of the instrument. Of course, the main is content, but beside the content, also you need to check the face. What does it mean, face validity? What do you think about the face validity? Can you hear me?
Hello?
Yeah, please.
Hello?
Yes, I can hear you, please. I think there is some problem, I think. Never mind.
Face validity during pilot study, during the distribution of questionnaires on the nurses or the participants in overall, and note
as you remember, we talk about now we are at the pretest, correct? I explained that pretest is a part of the study before doing the pilot study. That's always confusing. During the pilot study, we collect data among the target population in a small sample of target population, which is called pilot study. But pretest, as I mentioned earlier, it's a part of your study that you collect information and data according to the expert, based on the panel of experts, to be able to measure the face and content validity. The content validity is whether the content of the items. Can you mute your microphone? Sorry, thank you. The content validity, measuring the relativeness of the content of each items to the variable of interest. For example, if you want to measure the job satisfaction, or for example, stress or anxiety or anything else, correct? You need to make sure that the content of each items are related to the variable of interest. The face validity is something related to the grammar, wording, the form of the questions. So this can be, both of this kind of validity can be evaluated based on the panel of experts. Once you complete the first phase of the validity, then you can move to the statistical validity. And for a statistical validity, of course, we need to do a pilot study. So we have different types of statistical validity: the construct validity, the concurrent validity, and predictive validity, which is called criterion validity. And of course, beside that, we will be able to measure the reliability of the instrument. This slide shows different kinds of validity and also reliability. So let's start with the first part, which is the, what do you call it, the content and face validity. These are 4 points that you need to consider when you design a questionnaire: the content that you want to ask, the wording, what do you call it, the sequence of the items, and also the layout. All of this should be based on a standard, what do you call it, procedures. The face validity, as I mentioned earlier, can be evaluated by a group of experts. So I will show you later how you can do that, how you can measure it. Because in social science, in the human-based science, correct? So the reason that we need to design a questionnaire, because many of the variables and what do you call it, outcomes are subjective. So they are not objective. So when you want to measure the body temperature, it is an objective variable. You can measure it directly. But when you want to measure the stress or anxiety, it is a subjective variable. It cannot be measured directly. So that's why you are trying to measure it indirectly through some items or measure indicators. So that's why for the subjective matter, we design a questionnaire. And of course, when you design the items and questionnaire, it should be easy to understand. And all of these are related to the face validity. The content validity, as I mentioned earlier, it is something about relativeness of and logic. It's a kind of logical validity, and it's measured the what do you call it? How the items can represent the aspect of the variable of interest. So both of this kind of validity, as I mentioned earlier, can be evaluated by a group of experts. So, but before moving to measuring the content and face validity, I have a question. How many types of questions usually we use in the research? Sometimes we develop, sometimes we adapt, and sometimes we adopt a questionnaire. Can you tell me what is the difference among these three types of questionnaire? Development of questionnaire, adaptation, and adoption. Hello?
Hi, Doctor.
Yes, please.
Can I try again?
Of course.
Yeah, I think the development is about you constructing the questionnaire from scratch, from zero, while adapting is you are using the original questionnaire and adapt it like adapt and translate into the local context, while adopting you are using the original questionnaire as it is for your study.
Thank you. Yeah, thank you very much. Very clear. So when developing means you have an instrument and you start from scratch, you design by yourself. Adaptation means you have some new related and similar questions, the instruments, and you try to combine them. And it's always with big modifications. And adoption means you don't change too much. You use the original questionnaire as it is. For example, we know that there is a questionnaire named DAS, depression, anxiety, stress, correct? And many of the researchers, they use the original instrument. We have some well-known and worldwide accepted questionnaires that you can use it. These are adoption. Of course, sometimes you need to translate it. That will be called cross-cultural adoption. When you translate it, of course, and when you bring a new questionnaire from different context to a new context, of course, you need to do cross-cultural adaptation. But basically, we have three types of questionnaire: at the development, adaptation, adapted, and adopted. The first two type of the type of questionnaire needs to be subjected to face and content validity. And for measuring the face and content validity, there are several index that can be measured. The famous one is the CVI, the Content Validity Index, and also the CVIS, the scale content validity. In this slide, you can see all these different type of the content validity. The CVI, we have a scale CVI and ICVI, in item and a scale. I will let you know how you can measure and quantify the X for validity.
Hello?
Yes?
Please, Doctor. I want to ask about content validity. Used on development validity, instrument, and adoption.
Yes.
Or in all types of this.
Ideally, you can do it for all, but usually we don't recommend to do for the adoption. When the instrument is already adopted, you don't need to do the content and face validity unless you translate it, which is called cultural adoption. That is different story. But of course, for development of instrument and adoption of a new instrument, because when we talk about adoption means you have a big modification, you gather from different sources the items to form your questionnaire. Of course, for that kind of questionnaires, you need to measure the content and face validity by the experts. So means the pretest should be a detailed pretest with calculation of the CVI, in terms of the ICVI and SCVI. So, can you mute your microphone? Sorry. Thank you. So, how we can measure the content and what do you call it, face validity? So, this is the form that I already prepared for. I will share with you all the slides later, and also some of the data sample and softwares that I will show you later. So this is the form that you can use for measuring the content and face validity. The last two columns actually are necessary, but the first two columns are not necessarily, because when you want to develop, of course, you can add the first two columns. But most of the face and content validity are referred to the last two columns. So what you need to do, actually, you prepare your questionnaire according to this, what do you call it, template, and then you can send the questionnaire to the experts and let them to rank and rate the degree of the relevance and also the clarity of each item. Clarity refer to the face validity, means whether the items are clear in terms of the wording, in terms of the grammar, and also the structure. And the relevance refer to the content validity. So what you can do easily, you can, and also, of course, you need to let them to give you, if they have any extra comments, further comments in details. So this is the, what do you call it, the standard form for measuring the face and content validity. And the rating will be 1 to 4 for the relevance. Of course, for the clarity also, it's 1 to 4, but you have to change the wording here. So this is just a sample. Once you collect data among the experts, and the minimum number of experts, it is recommended by 5. It should not be less than 5. Of course, much more experts, better. But it should not be less than 5. Once you collect the information, then you will be able to calculate the CVI and also SCVI. So suppose that we had 10 items in this example, and we had 6 experts. So each item actually ranked based on 1 to 4. And remember, if the experts rank it 1 and 2, we consider it 0. 3 and 4, we consider it 1. So means when we need to coding the data later. So that codes can be used for calculation of the CVI. So if any expert rank the items as 1 or 2, will be considered 0. Means not accepted. And if they rank it 3 and 4, then we will consider it as accepted. So as you can see here, out of 6 experts, 5 experts accepted the first item. So means the ratio of 5 divided by 6 is 0.83. 0.83 is CVI. And then you can see how we can calculate the average of the ICVI for each items as a measure of the scale content validity of index. So we have another kind of scale item validity index, or universal agreement. The universal agreement is UA, is another measure beside SCVI, which is the average arithmetic mean of all ICVI. There is another measure which is called UA, or universal agreement. The universal agreement means how many items receive 100% agreement from all experts. As you can see here, 4 items out of 10 items have been received full agreement. That's why 4 out of 10 means 40%, 0.4. And this is called universal agreement. But mainly in many articles, what you need to report is CVI and SCVI. The acceptable level for the SCVI is recommended. Some of the, I put here 0.8, but we have some references that mention 0.7. Of course, the number of the, what do you call it, the experts also can affect on the cutoff point for the CVI. This is another, what do you call it, table, shows that how we can, what do you call it, as you can see here, this is the end, is the number of the experts. If you have more than 5 experts, the cutoff point is recommended 0.83, 6 experts 0.86, and above 0.7 experts, the cutoff point is 0.7. So means 0.7 or 79% is the cutoff point for acceptance of the content validity of each item. We have another measure of the content validity, which is content validity ratio, that I skip it because no more it is used in research. So we have too much issued points that I need to share with you. That's why I just skip this one and move to the Kappa. Beside the CVI, there is another statistical measure which is called Kappa Statistic, that it is a measure of the inter-rater agreement or reliability. And beside the CVI, it is recommended to calculate the Kappa. Why? Because the Kappa is something beyond the chance. It is degree of agreement beyond the chance. So if you want to publish a paper, I recommend you to report both CVI and Kappa. The CVI is a simple, what do you call it, ratio of the number of agreed experts to the total expert, but the Kappa is a statistical measure that can be calculated, and it is a, what do you call it, it is free of chance measure. The evaluation for the Kappa also is above 0.74 is excellent, but between 6 and 0.74 is good, and below what do you call it, 4 is not acceptable. This is the formula that you can calculate the, what do you call it, the Kappa. But of course, before using this formula, you need to calculate the PC. And the PC for, what do you call it, for the probability of chance agreement. Then the Kappa actually is a CVI, corrected version of the CVI, after excluding the, what do you call it, the probability of chance agreement. So, but you don't need to, what do you call it, calculate it manually, because I already prepared this frame, this, what do you call it, this template for you, and I will show you how you can use it. The way that you can report the results will be like this table. This is academic style for table. As I mentioned, for the relevance and clarity, you can report the CVI and also the Kappa. So, for example, these items, some of the items have been changed in terms of domain because they were not related to that domain according to the consistency with that domain. Some of the items, as you can see here, all are validated. Some of the items were excluded. For example, the item number 6 and 7, in terms of the relevance and clarity, they were less than the cutoff point. That's why they were excluded. Some of the items were corrected. Some of the items were 100% validated. So this is the academic style for reporting the result of the face and content validity. So, but how we can, what do you call it, calculate it? Let me to share with you my another screen. Can you see my screen now? Can you see the screen, the Excel file?
Yes.
Okay, so actually I make it easy for you. What you need to do, as you can see here, I already hide it. So actually what I did for you, you just need to key in the total number of experts. In this column, let me to hide it. So in this column, what you need to enter is the number of experts, and this column is the total number of experts who are agreed. So for example, for the first item, out of 6 experts, 5 experts agreed. And then automatically, as you can see here, the CVI and Kappa will be calculated. If I change it, for example, to 4, as you can see here, the Kappa and CVI will be changed automatically. So you don't need to calculate. Yes.
Dr. Mo, can you share your screen again, because someone else is presenting right now?
Okay. Now Salman joined is presenting. Can you?
You can just override him.
Okay. Now, can you see my screen now?
See your screen.
Yes.
Okay. Everybody can see. Okay. Now I explain again. So these are the items. For example, in this research, I had 10 items, and this is the number of experts. For example, I had 6 experts for all the items. So you can drag and drop more items, and this is the number of experts who were agreed. So, for example, you just key in the number. So what you need to key in is only this M and N columns, and then you just copy and paste the last 2 columns. Is it clear? So look at here. If I put 6 and 6, so then the Kappa and CVI will be 100%, 1. So what exactly you need to do? You need to do is just copy and paste these 2 columns. Of course, this is for the content validity. The same things can be done for the face validity. So means you can use the same calculator to calculate your Kappa and CVI for both relevance and clarity. I will share with you this calculator later attached with the PowerPoint and some other resources. Any question till now? No question? Fine. Okay. So this is the face and content validity. And you need to make sure that if you are developing or if you are adapting a questionnaire, you must present all this kind of information to make sure that logically the instrument is a valid instrument. One more thing that I want to recommend you, I use this opportunity. Please, if you design or adapt a questionnaire, please do not use too many items. I saw some of the students and researcher questionnaires that include more than 100 items. So have you heard about the fatigue effect? The fatigue effect. Have you heard about that? No response. What does it mean?
Not sure, Doctor.
Okay, so remember, when you ask many questions, the accuracy of and the concentration of respondents on the first part of questionnaire will be totally different from the last part. Correct? Because they become tired and fatigued, so sometimes they will lose their concentration and they just want to finish it. So I saw some of the researchers that they use more than 100 items. I had a student a few years ago. The total number of items was 140 something. So of course, the subjects especially depends on their age groups, socioeconomic levels. Sometimes, even for myself, I receive a questionnaire. One of the researchers from USM shared a questionnaire. When I reply to items, actually in the last item, I feel so tired, and then I just try to finish it. So the accuracy and concentration of respondents, when they answer to your items, your questions will not be same. And there will be a bias, and that bias is called fatigue effect. So please remember, using too many items is not recommended, same as few or minimum less than 5 items. So when you design a questionnaire, when you want to use a questionnaire for measuring subjective variables, the optimum number, if you are adapting a questionnaire or developing questionnaire, I recommend to stick by 5, above 5. Why? The reason is that maybe you lose some of your items during the content validity, and maybe you lose some of your items during the statistical validity. And the minimum recommended number of items to measure a subjective phenomenon is 5. You cannot measure the stress or anxiety or satisfaction or self-efficacy by only 2 items or 3 items. It is not enough. Because these are multiple aspects, and you cannot measure the stress only by single items. It will not be accurate. That's why we designed the items and questionnaires to measure these subjective variables or latent variables. So remember, when you are developing or you are adapting, this is based on my experience. I had a student in management. Unfortunately, he adapted a questionnaire, and for each variable, he only used 5 items. And during the statistical validation and analysis, we found that he had to drop from some variables or components 2 or 3 items, and only 2 items remain. Remember, if you want to use a statistical analysis like AMOS or a structural equation modeling, so 2 items sometimes impossible to run your analysis. So remember always to use adequate number of items.
Dr. Mahmoud?
Yes.
Are you presenting something?
Not yet. I just talked.
Right. Just to confirm.
Yeah, thank you. Yeah. So remember, the number of items are very important. But of course, when you adopt a questionnaire, you don't need to change it, and you cannot change it, of course. So you just need to stick to the original question. But for the adaptation and adoption, better to start at least 30 or 40% more sometimes, because we are not what will be happen during the statistical validation and logical validation. Any question till now? Okay, so let's move to the statistical validation. So you remember I talked about the pilot study. The pilot study, remember, all the validity studies must be done before running the main study. So we do this kind of validation during the pilot study. We need to make sure that statistically also the instrument are a valid instrument. As I mentioned, we have 2 types of statistical validation: the criterion and construct. The criterion validity also can be divided under 2 types of validity: predictive and concurrent validity, and construct validity under convergent and divergent validity that I will explain later. Let's start with the criterion validity. Can you see my slide now?
Yes.
Okay, that's good. Thank you. So this kind of validity actually usually used to measure the ability of your instrument for prediction of another outcomes, this criterion validity. And for example, just make it simple for you, and then we go how you can calculate this kind of validity. Suppose that, and logically we know that the stress and quality of life is related, correct? Am I right? It is already proven, correct? That if you have more stress or anxiety or depression, correct, the quality of life will be lower. It is negatively correlated. So, and suppose that you want to use you want to check the validity of your instrument, which is going to be used for measuring the stress. So beside collecting data during the pilot study for your main instrument, may you use the quality of life instrument as well. And then you try at the end of pilot study to try to correlate between your main instrument and the outcome. If the outcome is something can be related with your main research variables. There are two types of criterion validity. First is predictive, and then second is concurrent. The method of measuring of statistical analysis are same, but conceptually, the predictive validity means your research variable can be used to predict another outcome, and concurrent validity means there is another instrument can measure the same variable that you designed your questionnaire to measure it. For example, I want to measure the pain score. There is a well-known instrument, validated instrument that measure measure the pain score. At the same time, you are going also to check the validity of your instrument that measure the same things. So in this case, it is called concurrent validity because both instruments measure the same things. So how we can check the criterion validity, I mean both predictive and concurrent validity through the statistical analysis, and the statistical analysis is correlation and regression analysis. Sorry, give me just 10 seconds. I will be back. Okay, so back to the slides. Look at here. In this example, the DAS is an instrument, well-known instrument that measure the the depression, correct? So, and the new instrument that you design also is going to measure the same outcome. So, and what we do, we try to collect both data for both instruments through a sample. In your pilot study, you administrate both these tests among the same sample, and you try to correlate it. If these two instruments are highly correlated, it means your instrument is a valid instrument. Correct? As you can see here, this is another example. There is two scoring systems, and both scoring systems, designed to assess the bradykinesia. And then, as you can see here, this is based on task, and this is based on some measurement, electrical measurement, probably. So the observation between these two instruments, this questionnaire, this scale based on a scoring scale, and the instrument are highly correlated. It means the scoring system, this questionnaire is a valid questionnaire because it is highly correlated with the instrument results. Same things can be done for the predictive validity. As I told you, the predictive validity also can be used to measure the criterion validity. Statistically, we can use the same techniques. Let me to show you by the sum of data. So as you can see here, this is the data. We have two questionnaires, GHQ for the mental health and also STL-19. these two instruments are two type of measure to measure the mental health. So the GHQ, this is a real study. GHQ total, actually, the GHQ already developed, validated, and cross-cultural validation in Malaysia. These students try to, adopt this instrument in the same context, because SCL19 has more items, almost 90 items, but GHQ has only 28 items. And he tried to use the SCL19 in this study. Why? Because SCL19 has different, or more sub-scales or dimension. So to make sure that this instrument is a valid instrument, in this study we collected both GHQ and SCL19. And what we need to do, we just need to correlate these two variables. So the total score of the SCL19 and GHQ will be correlated by using the Pearson. Of course, you need to check the normality of data. If data are normally distributed, you can use the Pearson. Otherwise, you have to use the Spearman. But look at here. The correlation coefficient between the score of the SCL19 and also the GHQ is how much? 0.755. Usually the cutoff point of 7, it is considered a strong relationship, because if you Google it, you can find the, let me show you. If you Google correlation coefficient classification table, the correlation above 0.7 is called very strong relationship. So look at here, above 0.8, it is called very strong. 0.5 to 8, we have different classification, but usually 0.7 is considered as an acceptable level for the relationship between two variables. And in this study, as you can see here, we have a strong relationship between the score between the SCL19, which the students try to apply for the first time, with the well-known mental health measurement, which already validated in Malaysia. So if you want to draw the chart, also you can you can draw the scatter plot between these two, the simple scatter, and then you can just draw the scatter and GHQ and run it in a SPSS. So, and then you just double click, and then you can draw the line. This is the line. And also, if you need to add the equation, also you can add, if I'm not mistaken, yes, the equation is there. And also the RS score also is here. So this is the line. Of course, we have some discrepancy here. Some of the outliers, if you remove some of the outliers, maybe you achieve a better fitting between these two instruments. But overall, the correlation between these two instruments was 755, which is acceptable and strong, can be considered as a strong relationship. The same techniques and the same approach can be used for predictive validity. Suppose that, let me to check whether I have data sample for this. No, I don't have. So, but suppose that this was quality of life and this was stress. Then you can correlate between these two as same. The statistical analysis will be same. You can use the correlation coefficient, and also you can draw the fitting line and look at the scatter plot. So these are the two types of criterion validity. Any question? Okay, that's good. So this is the rule of thumbs for the interpretation of the R, or correlation coefficient. And this is the slide. So now we move to the construct validity. Have you heard about the construct validity? What does it mean? Construct validity. Can you hear me? Something wrong with the meeting. Oh. Can you hear me?
Yeah.
Yeah.
Okay, thank you. So what does it mean? Construct validity. What does it mean?
Okay, the constant validity, I think the degree to which, by which the instrument can test the or measure the purpose or question of the study.
Well, first of all, remember the construct validity is a statistical validity, correct? It's a method of the it's a statistical method for measuring the validation. So look at here, it's under statistical, convergent and divergent. Okay, let's concentrate on convergent validity. What does it mean, convergent validity?
Hello?
Yes, please.
Constant validity used to measure the test of hypothesis or theory in the study. So actually to test the hypothesis or theory they measure.
I cannot hear your voice clearly, sorry. Your microphone is very noisy.
Okay.
It's okay, never mind. This is the problem during the MCO always for the online classes. So before moving to the construct validity, I need to ask you, what is the latent variable? The latent variable is a hidden variable that I mentioned earlier. You cannot measure it directly. So always we estimate it indirectly through some items. So the construct actually refer to a group of items that measure any variables. So that is called, what they call it, construct and latent variables. So the latent variables consist of some of the observed items or what they call it, manifestation. So this is called construct. In terms of construct validity, we have two types of validity, convergent and construct validity. But before moving to the what they call it, measuring the construct validity, I want to what they call it to mention about two types of construct. Look at here. This is a construct, correct? So look at here. This is the items. Can you see the slide?
Yes, doctor.
Okay, so this is the latent variable. Of course, each items that you design is not 100% accurate of measure for the variable of interest. Always these items are biased. So, but this bias should be small if you want to use it as a measure or as an indicator to measure the variable of interest, correct? So means the observed items is your items. They always include amount of bias that can be measured later. So during the construct validity, we try to keep those items that they have low amount of error. This is the latent variable, for example, the math anxiety. And for that math anxiety, the researcher designed these 5 items. So of course, it does not mean that these items 100% shows the amount of the math anxiety. If people answer to this question, the answer of the respondents to each item is not 100% accurate measure for the, what do you call it, for the main variable, which is the latent variables here. That is why you need to understand, you need to be able to calculate the amount of that bias. If any item has more bias, that should be deleted from the, what do you call it, the construct. Am I right? The construct validity and a statistical method for construct validity analysis are those methods that let you calculate the amount of contribution of each items, or also, in the other word, calculate the amount of the bias or error of each items. Is it clear now?
Hello?
Okay. Let's. Yes.
Hello? I would ask about the content validity. Measured before content validity or both content validity? Construct validity.
If you remember, I mentioned that in all research, always we start with the content validity and face validity in pre-test through the expert validation. Once the experts confirm and validate the instrument, then you can run the pilot study, and then you can measure the statistical validity of the instrument. This is the next step after pre-test, after content and face validity.
Yeah. Content validity used to test item in the instrument and demographical data, or only for questionnaire items.
No, only for the questionnaire item. We are talking about the construct. Remember, there is no talking. We don't have any. What do you call it? Yeah, of course, the other tests, statistical tests that we can discuss later, but initially you need to, look at the construct first. We just look at, because we are talking about the construct validity. This is the construct validity. Of course, there are different kind of validity that you can, measure the homogeneity of we call it invariance, analysis of the questionnaire or instrument across different level of maybe socio-demographic variables. Usually, for example, if you want to test whether the instrument has same reliability across different age groups, across different ethnic groups, religion, that is another different, part that we will talk later. But right now, we concentrate only on the construct. So when we talk about construct consists of items and related.
Mahmoud, sorry for disturbing.
Yes.
Someone just decided to present now, so can you present your screen again?
Oh my God.
I'm so sorry.
Can you ask him to stop presenting? You send a message to them.
Yes, we did put in the chat.
I think the Microsoft team is much more better or Zoom, because we can limit the sharing of screen.
Yes, we'll try Zoom or Microsoft Teams next time.
This is much more better. Okay, can you see my slide now?
Yes, we can see your slide now. Thank you.
Okay, welcome. So this is the construct. So, but before moving to measure the construct validity, you need to understand different type of construct. I hope that you hear about the formative and reflective construct, because the way that we deal with formative and reflective construct are totally different when we do the statistical validation. Have you heard about the formative and reflective construct?
Yes, Doctor. We are.
So, formative construct are those constructs that the items which are going to be used for measuring the variable, the level of the variable, are totally independent. Indicators are totally independent, and they are not correlated logically and statistically. Why? For reflective construct, the items are interchangeable. The items are highly correlated. And the direction of the causality is from latent variable to the items. Look at here. This is two typical example of the formative and reflective construct. Look at here. The first construct is reflective. Why? Because 3 items, R1, R2, R3, are highly correlated. Because if anybody answered to the first question, for example, based on the Likert scale of 1 to 5, for example, 5, it is expected to answer to the other items also high. Because logically they are correlated. Because when you eat healthy food, of course you have a balanced diet and you don't eat junk food. For many of the questions are items in the social science and psychology reflective. But it is not a general rule. In some cases, we have items that are not necessarily correlated. They are independent. Look at the next, in the right side, the formative construct, the health. As you can see here, for the health, we have 3 items. And these items are not necessarily correlated. Maybe you have a good balanced diet, but you don't exercise at all. And also maybe you don't have get sufficient sleep. So the items are not necessarily correlated. In this case, we call it formative construct, and here is reflective construct. So this is very important to understand the nature and the type of the construct that you are dealing with. Why? Because statistical methods are totally different. If you want to measure the validation for a reflective construct, the statistical techniques and softwares are different from the formative. Many of the students, unfortunately, and researchers, they use a statistical analysis for the formative construct, which are not which are not suitable for that kind of construct. For example, Amos is a software for measuring the construct validity. That software only can deal with the reflective construct. So if you have a formative construct, you cannot use the Amos. Why? PLS, for example, Smart PLS is another software, or RAP PLS. These are softwares that can deal with the formative construct. And unfortunately, I faced with some of the students that mistakenly they use and they treat their variables as a reflective variable, while their original construct were formative construct. And mistakenly, they remove many items. When they develop their measurement model, when they develop the test of the hypothesis model, they drop many of items. Why? Because in reflective construct, the concept is correlation among the items. And Amos, for example, or QS or other softwares, they work based on that. Of course, the loadings will be high if they are highly correlated. And I saw many students and researchers, they mistakenly use this statistical analysis for the formative construct. This is very important, that you need to understand how you deal with this, two type of construct. Same for reliability. Let me to discuss for reliability here, because now your mind is fresh regarding to this concept. For example, if you have a reflective construct, since the items are correlated, you do the reliability using the alpha Cronbach. For example, this is the 5 items, for example, 7 items, and then you use the alpha Cronbach and then scale if item deleted, and this is the this is the result of the Cronbach alpha, 87, and all the corrected item total correlation are high. That's good. Why? Because the concept of the alpha Cronbach is based on the correlation among the items. As you can see here, the corrected item total correlation means the items should be correlated together. And if you look at the concept here is based on the correlation among the items. And while we know that the informative construct, the items are not necessarily correlated. So what will be happen if I do the alpha Cronbach for measuring the reliability of the formative construct? So you can see the alpha is low and some of the items are not correlated, and mistakenly some of the students, I saw that they drop some of the items. Is it clear?
Yes, doctor. Yes.
Yes, doctor.
Now, let's move forward about the construct validity. Okay, maybe you ask yourself, okay, if my construct is formative, what shall I do for measuring the reliability? What is your solution? Answer to me, please. Suppose that you have a construct and the construct is formative and you want to measure the reliability. What is the solution? Hello? Any answer?
No.
Have you heard about test-retest reliability? So remember, when you are dealing with a questionnaire that is basically formative, then you have to do the test reliability. The test-retest reliability is a measure of reliability that can be done for formative construct. For example, if you ask me, do you have a balanced diet? Yes. Do you exercise regularly? No. I get sufficient sleep each night? Sometimes. So, of course, the answers are not correlated. But if you ask me the same question, for example, after 1 week, you will get the same results. And then in this case, we do the test-retest reliability. Means for each items, we try to correlate the result of first and second assessment, test and retest. And for that, we need to calculate the ICC, inter-class correlation. So look at here. Let me to give you an example in SPSS. Suppose that people answer to this, the first item, based on the Likert scale of 5. 1, 1, 2. Correct? So these are the answer of peoples in the pilot study. So remember, we asked this question, the same question after, for example, 1 week. So if we expect people give the same answer, correct? Maybe some of them maybe change a bit. If the item is clear, if this question is clear, then we need to, this is the test and this is the retest. So what we need to do for each item, suppose that your questionnaire has 5 items and this is the question number 1. Same, this is the question number 1, Q1, and this is also Q1. So remember, these are the same measurement from the same subject, just repeated after 1 week or 2 weeks. So what you need to do, you need to calculate for the scale reliability only for these 2 items and then calculate the ICC, inter-class correlation. So if people answer same during the test and retest, then we can conclude that this item is reliable. Why? Because the people's feedback, the subject's feedback into the same questions was not changed. They are consistent over the time. Remember, when you do the test retest, make sure that you use the same sample. But for the test retest, the sample must be same. And the minimum gap in terms of time between test and retest should be at least 1 week. Of course, if you are dealing with some instrument in the lab or you're using some, device in the laboratory, for example, you are doing in sport science and you use the device to measure some stress on the muscle. So then you can measure this, you can repeat the measurement after a shorter time, maybe after 1 hour or 20 minutes. But for the questionnaire, it is recommended to do after 1 week because of the memory effect. So, and also don't do that after 2 weeks because probably you cannot control the conditions and maybe something happened during test and retest that can affect on their feedbacks. So that's why you need to concentrate, you need to collect data within the same sample 2 times with at least 1 week time. If you are dealing with the questionnaire and human-based studies and science. Any question? Fine. Okay, now. So back to the construct validity. Before moving to the construct validity, let's talk about the dimension, sub-scale, factor, components, and construct. There are some, similar terminology that, synonym terms that you can maybe, you can see in the articles or papers or statistical books. So usually the construct is equal to dimension or a scale or sub-scale or component in the statistical validation. And that can be achieved or can be calculated based on the exploratory factor analysis. So we have 2 types of factor analysis, confirmatory and exploratory factor analysis. Can you tell me what is the main function of the factor analysis? What is, when we can apply the factor analysis? What is the concept behind factor analysis? Are you familiar with the factor analysis? Can you hear me? Can you hear me?
No.
Okay, good. So the factor analysis is a statistical method,
Yes.
which works based on the correlation among the variables. So the main concept of the factor analysis is to categorize and grouping your variables based on their correlation. So you can divide and grouping the variables according to their relationship. Those variables which are highly correlated, they can form a component or a scale or domain or factor, correct? So as you remember, especially for the reflective construct, correct? For the reflective construct, the items are highly correlated. Let me to show you practically. So I have designed, for example, 20 items. Suppose that I have 20 items to design to measure the mental health, correct? So if I do the factor analysis using the exploratory factor analysis. I will explain the difference between exploratory and confirmatory later. Look at here. So I have 20 items. I don't know whether these items all are able to measure same things or no. There are some similarities among the items that can be differentiated and can be grouped. So in this case, we are not sure, especially when you are developing or when you are adapting a questionnaire for a statistical validation, for construct validity, you must run the factor analysis, exploratory factor analysis. Remember, sometimes a student asks me, Dr. Mahmoud, shall I use the CFA or EFA? Very simple. The answer is that if you are developing, if you are adapting a questionnaire for construct validity, you must do the factor analysis, exploratory factor analysis. But if you are adopting a questionnaire, you just take it and use it. In this case, to measure the construct validity, you must do the confirmatory factor analysis because you did not change anything. Correct? Okay. In this case, just assume that I have 20 items and I adapted these items from different sources and I combine all of them and I'm going to measure the mental health. So in this case, I do the exploratory factor analysis. Of course, if you want to know the details of exploratory factor analysis, there are a lot of tutorial video in the YouTube, and then you can explore more and find the details of this kind of analysis. I just want to introduce you how and when you can use this kind of analysis. Look at here. These are assume that these items all are adapted. So when I enter all this data under extraction, the PCA, there are several techniques. So usually the common method is principal component analysis. Of course, there are other techniques that if you are interested, then you can go through this teacher, the help, and then you can click on the help, and then the best teacher is here. You can find all these techniques here. What is when you can use this principal component analysis, when you can use the alpha techniques, the image factorings, or PCA. Anyhow, the common techniques is PCA, but if you are interested to know more, please go through the help system. So I just want to show it very simple and easy. Later, of course, the factor analysis is an advanced statistical techniques that you need to know in deep and more about these techniques. Unfortunately, they just follow the YouTube tutorial that are not very detailed. They are very superficial. I mean, discuss very simple on the concept of the factor analysis. But I recommend you to go and learn the details of this advanced and multivariate statistical techniques. So back to the factor analysis, I just click continue. The rotation, we use different rotation, Varimax, and if I just sort by size and then we suppress the coefficient or loading below 4. So if I run it in the analysis results, as you can see here, the 20 items were converted to the 4 components, correct? And each component, of course, the first component is the most important components in terms of explaining the variance, following by the second, third, and fourth components. This is the percentage of the explaining variance by each components, 38, 10, 8, and 50. And this is the cumulative percentage of the explaining variance. And let's just jump to this table. Okay, so at this table, as you can see here, the item number 10, 8, 12, 9, 11, 14, 13, all they came together under the first component. 4, 5, 3, 6, 7, 1, 2, all they came to same component. As you can see here, the factor analysis grouped, classified 20 items into 4 components, correct? And each component later, according to the context, according to the type or nature of each items, can be nominated to a certain name. For example, maybe we put it physical quality of life, mental quality of life, according to the items. I don't access to the items to show you. And then 3 is the environmental, and the last one maybe is the social quality of life. So it depends on the nature of the items. So this is the way that we can deal with when you are developing or adapting a questionnaire. Because under development, we don't have any assumption or idea about the structure of these items. That is why we do the exploratory factor analysis. And of course, there are many details in terms of the factor analysis that you can also learn from the references and resources. But what I'm going to share with you now, unfortunately, I saw many students that they do the factor analysis using the, using the SPSS. The SPSS is not, a perfect software for doing the exploratory factor analysis. I forgot to tell you that, as you can see here in the results, these numbers are called loading factors. The loading factors is the amount of relationship of each item with the construct. Do you remember this slide? Do you remember this slide? We said that the relationship between item and construct, correct? It's not 100%. I mean, the item is not 100% explaining the latent variable. Always it is bias. So the amount of loading means the amount of sharing of this variance to the latent variable. The rest is bias. So that's why the highest loading indicating a better measurement for that component through that items. So that the cutoff point for the loading according to statistical references is 0.5. Of course, 0.4 is also acceptable, but ideally it should be above 0.5. 0.4 is acceptable also for that's why if you remember, when I did the factor analysis under option, I suppress the small coefficient. Look at here, if I don't suppress the small coefficient, then you can see the results totally different. Look at here. Now, the first items is highly and positively correlated for the first component, while this item is not related to the component 2, to component 3, because the relationship between this item and the next 3 components is very poor. So means if I want to put this item under component 2, means I have 76% bias. And if I put this item under component 3, I have 93% bias. So this is almost, this value shows the amount of contribution of each item to each component or factor. This is called factor. So, but to make it clean, what I did under SPSS, I just select suppress small value less than 0.4. That is why when you do the analysis, you can see this clean table. And also what I did under factor analysis, I sorted by size. Because if I don't sort it by size, then it will be sorted alpha based on the order. Correct? As you can see here, it is not based on the component. The academic style is to just sort it by size and suppress based on that value less than. So Okay, one more thing that just I want to mention. Remember the test of the KMO and Barclay test of sphericity. So this is one of the assumption of the factor analysis that must be neat. The cutoff point for the KMO for the sampling adequacy. Remember, this sampling adequacy does not reflect the sampling size. Unfortunately, some people, they misinterpret this KMO as a sampling adequacy means the sample size. No, this sampling adequacy means how much total variance and covariance available among your data. If there is no covariance, which means there is no correlation among the items, then you cannot do the factor analysis. And the cutoff point for the KMO is 0.6. And also the Barclay test of sphericity, which is homogeneity of the correlation among all items, should be significant. If it's significant, then you can proceed with the result of the factor analysis. As I mentioned, this table shows the amount of the extracted factors or components. In this case, we have 4 components. But as you can see here, maybe you ask yourself, based on what criteria 4 components were extracted? The answer is here. When you do the factor analysis with SPSS, under extraction, the components will be extracted if the eigenvalue is more than 1. The eigenvalue is the proportion of sharing variance. I don't want to make it too much complicated, but as a cookbook, just learn the cutoff point is 1. That is why those components that they had the eigenvalue less than 1 were not extracted. But the problem is here. Is it statistically significant or not? This is the weakness of the SPSS, that cannot detect the significant number of factors. That is why you need to do another analysis manually before running the factor analysis. And that analysis is called parallel analysis. Have you heard about the parallel analysis? Do you know what does it mean? Yes or no? Hello?
No.
I cannot see your face. I cannot hear you. Sometimes less motivated to continue. Please. Okay. I'm going to give you a 5 minutes break now, correct? I will be back after 5 minutes to continue the next topics. Are you agree?
Thank you. Okay.
Welcome. Okay. So I will be back after 10 minutes. 10 minutes. 10 minutes is better. Thank you.
Okay.
Bye. Okay, shall we start?
Yes, Dr. Mahmood.
Okay, fine. Fine, thank you. So what is the parallel analysis? The parallel analysis is a method to test and define the significant number of the components that you need to extract from the factor analysis. Unfortunately, this kind of analysis is not provided by SPSS. And for that one, you need to use it with different software. One of the easiest way to do the parallel analysis is using the stat2do. This stat2do, actually, if you Google stat2do, let me to do it. If you Google stat2do parallel analysis, then the first link you can access to this online calculator. So if you click on that link, then you will lead to the page introduction about the parallel analysis, and then what they call it, then you can go to the program. You can go to the program, sorry, let me to find it, the parallel analysis. or maybe you can go to index. From index is better. Go to the P. And one more thing, Stat2Do is an online statistical software. Consists of many statistical tests with explanation. Sometimes if you don't access to any software, then you can go through the, what do you call it, this software. So this is the parallel analysis. Then you go to the program. Under program, what you need to define, go to the program computers. So what you need to identify is the number of the variables. In this study, in this factor analysis, the number of items that I had is 20, correct? So the number of items is 20, then I have to enter 20. And then the sample size. In this study, my sample size is 648. So you need to key in these two numbers, 648, and then the number of the iteration, just leave it as 100 and then calculate. When you calculate, then you will see a table below, and what you need to do, you just copy this table and then open Excel file and then paste it in an Excel file. So this is the table. This is the results of the parallel analysis. We have the average of the eigenvalue and then 95% confidence percentile, 95 percentile, what do you call it, the eigenvalue. This is based on the simulation data. Actually, if you read more about the, what do you call it, the factor, the parallel analysis, it explained that this concept is based on the simulation data, and that is why it is always fixed. With if you repeat, the numbers will be changed a bit, but not too much. So what you need to do, you need to compare the initial eigenvalue for each component, the number of the components, with the simulated data. So what I need to do, I just copy the result of the factor analysis of SPSS. I copy this one, and then I paste it here. And then I just take this number, copy, and then I paste it here. So what you need to do, you need to compare, this is the actual value, actual data, and this is the simulated data. So what you need to do, you need to compare the actual and simulated data. If your eigenvalue from actual data is more than the simulated data, you can keep the components. So the first component, shall I keep it? Yes. Why? Because this is more than this number. Actual data for the second component is 2.1, while here it's 1.3, so I can keep it. The next component is 1.78, while in the simulated data is 1.259, so I can keep the component 3. But look at here. My fourth component in SPSS, the eigenvalue was 1.015, while the simulated data is more than this. That is why, instead of 4 components, statistically, you need to extract 3 components. So if another way to show you can try to visualize this parallel analysis, if you select this and then go to line and then try to draw the line. As you can see here, the blue line is simulated data. The brown line is the actual data. As long as the components is above the blue line, you can keep it. So now we have 1, 2, 3 components, but the fourth component is below the blue line. So that's why the recommended number of the components for these items that I did the analysis is 3 items, 3 components. Then I need to go back to the factor analysis. Under extraction, I don't use this cutoff point as 1, because as I told you, this is not a statistically significant. So according to the parallel analysis, we must extract 3 factors and then we run it. So now, as you can see here, this is the Kmo Barclay Test. The communalities should be above 0.3 for each items. So this is the screening. Of course, if any item has a communality or variance less than 0.3, it should be dropped from the analysis. Now, as you can see here, we have 3 components, and total 3 components are able to explain more than 50% variance. That is good. The cutoff point is for 50%. If the total variance of all components is less than 450, this analysis is not, this factor analysis is not strong enough to be reported. So then you need to increase the sample and collect more data. But here, the total variance explained by these 3 components is above 50%, 57.58%, which is fine. So now I have 3 components. Look at here. The first component consists of these items, the second component, and the third component. The item number 15 has no loading in any component. So that's why the number of items number 15 must be dropped from the analysis, should be excluded from this, this analysis. So these items has no adequate loadings to be under each of these 3 components. That's why we have to remove these items. Some of the items, maybe you see they have loadings under 2 different components. So it is cross-loaded. So means the item number 6 can be related to component number 1 and component number 2. But since the difference is more than 0.1, then we can still consider this item number 6 under component 2. But remember, suppose that this item, let me to copy this one in Excel and explain there. Suppose that this item cross-loading was, for example, 7.5. So this item is cross-loaded. So means we cannot, this item was not, clearly related to the first or second component. That's why this item also must be removed. Any item which is cross-loaded also must be dropped from your analysis. But item number 15 also had a very low value below 0.4. That's why this item also must be dropped. This is the way that we can do and we can measure the construct validity if you are, remember again, if you are adapting or developing a question. Of course, maybe you ask yourself, what about the cross-cultural validation? For cross-cultural validation, since the construct may be related to the culture, again, it is advised to do the EFA rather than the CFA. So that's why we recommend to do the EFA if you want to adapt a questionnaire in different culture, even without changing items, only you want to translate it, because sometimes some of the items in the new culture, in the new context, maybe show different patterns. We experience that many times with some of my students, that when we adopt a questionnaire and we just translate it, of course, for translation also, you need to follow the well-known protocols for backward-forward translation. But for the statistical validation, remember, do the EFA rather than the CFA. Okay, so this is the method that you can do the construct validity if you are dealing with adapted or developed questionnaire. But the point is here, this statistical software is not a strong software to do the factor analysis. Recently, a group of scientists in Spain, they developed another software which is called Factor. That Factor can be easily and free of charge, can be downloaded from this Factor software. If you just Google it, the first link from a university in Spain, the Rovira Virgili. This university, Publica de, I don't know, Tarragona. So this software is available for what do you call it, two type of windows, 32 and 64 bytes. You can also what do you call it, find this is free download documentation, and also the instruction how to use, how to apply this data. Why I'm going to use, why I'm going to introduce you this software? This is because of the nature of this correlation, because of the factor analysis in SPSS is based on Pearson correlation coefficient. So as you know, the Pearson correlation coefficient is a quantitative method of measuring relationship between two quantitative variables. So it means if your data are quantitative, then okay, you can use the SPSS, PCA for doing the factor analysis. But you know, in social science, all the items that we are dealing with are not quantitative, they are categorical data. They are based on the Likert scale, correct? So for the qualitative data, you cannot use the Pearson correlation coefficient. So this is a problem that if still it's a common mistake among many researchers. Of course, there was no any option for us, but right now, this group of researchers and scientists, they developed this software, and using this software, unfortunately, you are able to do the factor and parallel analysis concurrently. So it means you don't need to go and do the parallel analysis with the stat to do. Everything's all integrated in the same software. And the point is here, as you can see here, the point, the strength point of this study, this software is that. So we have two types of correlation matrix. Pearson correlation matrix, which is for the qualitative, and polychoric or tetrachoric correlation, which is what do you call it, developed for the categorical data. Sometimes, for example, your items are binary data, 0, 1. So in this case, you cannot use the Pearson correlation coefficient to do the factor analysis. So that's why I strongly recommend you, if you are going to do the factor analysis for the questionnaire based on the qualitative information, categorical information, and instead of using the SPSS, please use the factor software. And fortunately, the latest version of the factor, actually, it is, mine is not the latest one because it is belong to 2015. Let's download the latest one and show you the home. And look at here, this is the software developed by these two researchers in 2020. The last updated is just a few months ago, and that is very strong. And also, as you can see here, there are a lot of papers published by these techniques. The strength of this software is not only the what do you call it, the polychoric. Also, they supported this software by using the what do you call it, the bootstrap approach. And you know, the bootstrap approach is a method that you can look at here. This is the number of bootstrap samples. The bootstrap is a what do you call it, resampling techniques that recently added to many of the statistical software. Of course, in SPSS, for example, there is bootstrap. For example, if I just go to the regression analysis, as you can see here, we have bootstrap. Bootstrap is a method of resampling to increase and to improve the accuracy of your finding. Unfortunately, this software, this factor software, able to do the bootstrap. There are other options for the what do you call it, even for the missing value, dealing with the missing value, outliers. This is a perfect software for doing the, what do you call it, for doing the factor analysis. As you can see here, for the factor models, there are 5 types. Even the principal component analysis, the, what do you call it, unweighted least square, and the maximum likelihood, and even the rotation. There are many types of rotation available here. But since I don't have data right now to show you, you can download this. You can download this, the latest version, and proceed with this instruction. If I'm not mistaken, there are some video that you can download the video and see the procedure of the analysis based on that video. So anyhow, since we don't have too much time and I need to explain some more details, I just skip and stop here. But please download this software if you are planning to do factor analysis for categorical data, for the questionnaire-based data. Please follow these techniques. And remember, when you want to do analysis, please use the polycorrelation, not Pearson correlation. So I saw some differences in the output between SPSS compared to analysis that I ran with the factor. Of course, the factor is much more accurate for the qualitative data. Okay, any question? No question?
No.
Fine. Okay, La. So now we move to the so now for the confirmatory factor analysis, the second techniques for the factor analysis is confirmatory factor analysis. But for the confirmatory factor analysis, you will be able to do the measure the convergent validity and divergent validity. So the convergent validity means how much the items within a construct are correlated. If the items are not correlated, or some of the items are not correlated with the scale, then you can drop it. Actually, this concept is same as loading in the factor analysis. Look at here, the GH15, if I change the cutoff point here to 0.2, maybe I can see that. So look at here, this component, this item GH15, the loadings in this component is how much? 3.7, So this is less than cutoff 0.4. So that's why this item has low correlation with the overall construct. So in other words, this item, what do you call it, did not meet the convergent validity with this construct. The convergent validity means how much the items within the same constructs are correlated. And discriminant validity means how much different items under different constructs are able to be discriminant, to be different. It should not be correlated. Suppose that if I have an item, for example here, look at here, the item GH10 under component 1 is 767, while in the component 2 is 24641. So actually, if these items was highly correlated with 2 other components, then these items were not discriminant, and it was not able to identify actually belong to which component. And one more thing, under factor analysis, when we have this structure, let me go back to 0.4. So as you can see here, these constructs are totally, what do you call it, discriminant from each other. Exploratory factor analysis already showed the divergent validity because it already created different components. So, but for the confirmatory factor analysis, we have different, techniques and softwares. So for this is a construct, for example, and remember, the CFA stands for confirmatory factor analysis. So, and this is also called measurement model. This, techniques, this analysis can be done through the structural equation modeling. So, means if you want to do the confirmatory factor analysis, you need to do the SEM. And there are two main type of statistical software for the CFA. One is AMUS, the well-known. The other is Smart PLS. The AMUS, as I mentioned earlier, it's very strong software if all the constructs are reflective. But if your sample size is small, if data are not normally distributed, if the construct are formative, then you need to move to the second type of the confirmatory factor analysis, which is called the Smart PLS. The concept is PLS SEM. There are many software. If you need to know more about the PLS AMUS, please, there are many resources in YouTube or some statistical books that you can learn these two techniques. Of course, for me, each of these two softwares needs at least 2 days workshop, because I ran the AMUS workshop and also PLS workshop for 2 days, because there are a lot of things that we need to learn when we do the CFA using these two software. But back to some terms that you need to understand is the loading factors first, and AVE, average variance extracted. So let me to show you by running a sample under PLS. The PLS is one of the friendly user environment software that you can deal compared to AMUS much easier. AMUS is a bit challenging because there are a lot of assumptions. For example, when you do if you do the measurement model, for example, you draw the model. So let me to show you. Okay, so for example, this is the model, and the questionnaire for all the constructs were adopted. So we did not explore. And when you run the analysis with the PLS algorithm, easily you can access to the information for the, look at here, this is the construct reliability and validity. If you click here, for each construct, you have the Cronbach alpha, the composite reliability, and also the average variance extracted. If the composite reliability and alpha are above 7, so then you say that this construct is reliable. And if the AVE is more than 0.5, then you can conclude that this construct, each construct is has met the convergent validity. So beside that, as you can see here, we have discriminant validity. Discriminant validity can be also achieved by Fornell-Larker criterion, and also the HTMT, heterotrait, monotrait. This is a new techniques to measure the, as you can see here, some of the constructs are highly correlated. So the red line means this variable, which is emotional illness, and the mental are highly correlated. They are not discriminant. So means we have to merge it. So despite in the model, maybe they use these two constructs separately, but according to these results, later you want to merge it. So discriminant validity means these two variables, two constructs, should not be highly correlated. If they are highly correlated, means they are identical. then you have to mix and merge these two together. So if I show you another study, look at here. In this study, initially the DAS I separated under three different components. But when I analyze it, I found that these three components are not discriminant. Let me show you what will be happen if, okay, originally the DAS has three components. Originally, DAS has three components. Depression, anxiety. So the items for the DAS 1 to 7 belong to depression. How easy? So, and then 8 to 14, 8, 9, 10, 11, 12, 13, 14 belong to the second, and the last 7 belong to, okay, so look at here, what will be happen? If I just make it simple. So if I draw this model, suppose that this is my model, and if I run the analysis by PLS algorithm, so if I go to convergent validity, reliability, everything's perfect, reliable, and one of the component, the AVE is less than 5. So it means we have to look at the loadings. As you can see here, some of the items, the loading should be above 0.5. So as you can see here, this number 2, the loading is less. So I have to drop it and then run it again. So now, back to results. Okay, it still is better, but it still is low. We go back and check again. So everything fine, but the last component has still low items. Ideally, the cutoff point for the loading is 0.7, but 0.5 can be kept if the AVE meet the threshold, which is 0.5. So the AVE here does not meet the 0.5. That's why I can still remove this item. If I remove this item and run it again, now if I go to convergent validity, perfect. Look at here. So what does it mean? The AVE values all above 0.5, indicating all the research variables. This, for example, this one, depression, anxiety, stress, all the loadings above 0.5 or 7, that is fine. And according to these results, the AVE value also above 0.5, it indicates that all the research variable or constructs, they meet the convergent validity. So means these 4 variables, these 4 constructs, they already met the convergent validity. That's fine. But we need to make sure that whether this variable and this variable and this variable are measuring different things or no. If they are highly correlated, means they are measuring same thing. They also should be different in terms of measuring the outcome or discriminant in a simple way. So if I go back and check the discriminant validity under HTMT, look at here. These 2 variables, latent variable 1 and latent variable 2 is highly correlated. Latent variable 2 with 3 also is highly correlated. Means 1 with 2, 2 with 3, they are highly correlated. They are not discriminant. So what's the point? So means despite in this study, originally the questionnaire designed to measure different variables. Let me change the name. This is the depression. This is anxiety. And this is, for example, stress. So So as you can see here, when I did the analysis by PLS under discriminant validity and under HTMT, the anxiety is highly correlated with depression. The anxiety is highly correlated with stress. So means anxiety should be merged because they are same. The value, the cutoff point for the HTMT correlation, this is HTMT ratio, is 0.85, and they are all over more than 0.85. That's why, if you remember what I did for this study, I merged all the items together because these three sub-scale, which initially, according to the questionnaire, were under different sub-scale of mental illness, mental health, were not discriminant. That's why what I did, I merged all of them together and then use it as one construct, and I measure it as DAS. I'm not able to study these three variables separately because they are highly correlated. And when they are highly correlated, in a statistic, we say that there is collinearity issue. And as you can see here, there is a collinearity issue statistic. Why? Because if I consider anxiety, stress, and depression separately in the model, since they are highly correlated, there will be collinearity statistic. And of course, the results will be biased and overestimated. So this is the concept. This is the concept of convergent and discriminant validity. Of course, if you are dealing with Amos, of course, Amos will not give you directly the measurement. Let me to show you one of my Amos work. If I find it, I don't have the sample here. Anyhow, so when you create the measurement model with Amos, also it's a bit challenging because before measuring the correlation, convergent, and discriminant validity, then you need to fit the model. And for fitting model, there are a few criteria that need to be met by the adjustment of the model, removing the items, correlation among the error terms, and a bit challenging. But the results actually will be same as PLS. So these are the points. But remember, I explained in the PLS about the, about the reflective model. So look at here, only as PLS you will be able to measure the formative construct. Look at here, these all items are reflective, correct? So as you can see here, the direction between indicators, and construct all reflective. So in almost also all of them are reflective, because even if you design the Amos, and remember, whatever I'm teaching you now is all about this is for example, a measurement model. So look at here, when I run the measurement model, some of the items are correlated, some of the items are missed. So now, when the model, look at here, this model still has a problem because it's not fitted. That's why I cannot measure the construct validity because this model has a lot of problems. So now, anyhow, if I want to skip and show you how you can, measure the construct validity and convergent validity under, Amos, then you can use this StatTools package. a StatTools package is from StatWiki website. So StatWiki is a website developed by Dr. James Gaskin, and it is one of the best platform to improve your skills and knowledge for learning the AMUS and also the PLS. I like this website, and he is the famous one that has a lot of tutorial video for the AMUS and PLS. So this is also the StatTools package that you can download it from his website, StatWiki. So if you want to learn about the EFA, CFA, PLS, M+, so all the videos are available here. You can learn from the basic. Okay, so this software that I use as a utility software to calculate the convergent validity and discriminant validity for the AMUS can be downloaded from his website, because the AMUS will not give you directly the information to measure the convergent and discriminant validity. You need to copy and paste some of information from the what do you call it, from the AMUS output in that website. For example, if I go to estimate under Scholar, I need the correlation first. This is the correlation I need to copy, and I need to paste this correlation, what do you call it? As you can see here, paste the correlation table in A1. I just paste it. And in F1 correlation, the standardized regression weight or the loading factors. So from this standardized regression weight, I just right click, copy, and then I paste it in F1, and then right click. So now, as you can see here, the outcome shows that we have a lot of problem for this measurement model. We have a lot of discriminant validity issues. And also the convergent validity, fortunately, we don't have problem because all the AVEs are good. But unfortunately, some of these components are highly correlated. Look at here, NFC and PJ are much more correlated than inside correlation within the construct. So means some of these constructs are not discriminant, and you must do adjustment and cleaning your data, or sometimes you need to merge. For example, maybe I decide to combine the PJ and NFC together because they are highly correlated. So they are not discriminant because they are measuring the same things. So means if I use a path model using this different construct, then there will be a bias. Same for the PLS. Okay, what I wanted to share you, sorry for this a bit complicated phase, but no choice. This is an introduction to the construct validity. Of course, as I mentioned, if you want to learn more about the construct validity, you need to sit for 2 days workshop for each of them, or you need to continue by yourself. But it is a bit complicated analysis and of course advanced method. So it cannot be covered within 2 hours or 3 hours workshop or talk. The main target of this talk is to introduce you what exactly you need to do when you are dealing with a questionnaire adaptation, development, or adoption. So look at here. You remember regarding to the type of a construct in PLS. Sorry, in AMUS, as you can see here, when we create a new construct, always it is initially is reflective because from the latent variable to the items. While in PLS, we can easily switch based on formative and reflective. So now I have, for example, 3 formative constructs. Correct? So this is the only software that you can deal with the formative construct at the first order or item level. There are, of course, there are advanced techniques in the second order formative or second order reflective model, that is a bit beyond my topics for this, what do you call it, the statistical. Any question? I'm sorry if I confuse you, but remember that just I want to introduce you the techniques and the methods that you need to apply. Any question? No question? Shall I ask you the question?
No problem.
Okay, so this is the software that I explained all these things. Yes. Okay, this is the and as a final conclusion, I just want to remind you, because we already talked about the reliability, about the retest reliability. I explained for you about the reliability and some of this, what do you call it, issue about the reliability. But as a summary for the validation, I just want to mention that if you are going to develop a questionnaire, it is an ideal situation. It's better to do all these type of validation, face and content, concurrent or predictive, not both of them necessarily, and then of course convergent and discriminant validity. For the adoption, the yellow part, I mean the criterion validity, is optional. For the, what do you call it, logical face validity and content validity, it is recommended. But for the adoption, no, we don't need to do a pre-test because it's already validated. And also we don't need to do a criterion validity. What you can do for the adoption is only construct validity using the CFA, not EFA. EFA can be used when you develop or you adapt a questionnaire. Is it clear?
Yes.
Yes.
Okay. So one more thing that I'm going to share with you for the last part. Remember, when you are doing the reliability for the scale, do you remember we use the alpha, correct? So alpha can be used when your items are based on the Likert scale, but sometimes your items are binary items, 0, 1. So if you have the dichotomous or binary items, please do not do the alpha Cronbach. Instead of the alpha Cronbach to measure the reliability, please measure the KR20, or what do you call it? We call it KR20 or Kuder-Richardson coefficient. So of course the SPSS has no this option. Again, if you have binary data and you want to measure the reliability coefficient for the binary items, please report the Kuder-Richardson coefficient through the stat to do. So means, again, if I back to stat to do, index, and then go to the K, under K, as you can see here, we have Kuder-Richardson. So you go to the program. As you can see here, for example, here I have 4 items, 0, 1. So you just copy paste your data. Let me to show you another example. So, for example, this is the items. Suppose that I have these items, all of the items are 0, 1. If I want to measure the reliability for this questionnaire, I just copy and paste my data here. Control paste and then calculate the Kuder-Richardson. So as you can see here, my KR is 89, above 0.7. The same rule as alpha. If the alpha is more than 0.7, we concluded that the scale is reliable. Same for the KR20. So, but remember, the KR20 cannot be achieved, cannot be calculated by using the SPSS. Clear?
Yes.
Yes, sir.
I think now this is the, if you open your camera, this will be the situation. Okay.
Thank you, Dr.
Yeah, if you don't have any question, I'm going to finish my session now. And
Hello?
yes, I'm hearing.
I would like to ask about what differentiate between scale and the questionnaire. And are there in scale use constant validity and content validity and all these
Questionnaire, instrument, a scale are synonym. So of course the questionnaire maybe use different what do you call it, a scale based on different type of measurement scale, because we have a scale and we have measurement scale. Measurement scale means the scale that you measure the variable outcome between 1 to 5, 1 to 7, 1 to 9, 1 to 2, different. But the scale, actually, what we are calling about the scale. Scale means then the limited number of items that measure a single, what do you call it, variable of interest, a single subjective variable.
Hello, Doctor.
Okay, thanks.
Hello.
Yes.
Yeah. Hello, Doctor. My name is Yuva. I have a question. So, can we use AMOS to calculate EFA?
No, AMOS and PLS, as I mentioned earlier, can be applied if you want to do the CFA.
CFA. Okay. So, EFA is better to be calculated using SPSS.
The factor software that I introduced you.
Factor software. Okay.
Yeah, SPSS is a bit outdated, and unfortunately, for last 10 years or more than 10 years, this option under SPSS has not been changed or improved.
Okay.
Still the options and the protocols for analysis is same. I mean the algorithm behind the analysis was not changed for last 10 years. That's why I strongly advise you, if you want to publish a paper in high impact journals, please update your factor analysis using the software. Of course, if you are familiar with the R programming, there are some what they call it package under R also can do the factor analysis. But to me, this factor software is excellent, amazing.
Okay. Thank you, Doctor. Thank you.
Hi, Dr. Mahmood.
Yes.
I think you can check the chat area because there's a few questions there.
Oh, sorry. Okay, one, they ask them how to access the PowerPoint. Exactly after we ended the class, I will send for you the PowerPoint and my statistical software for all the participants. And can we access? Yeah, that's all. No more questions. Any question? Thanks, God. Okay.
Okay, thank you.
You're welcome. You're welcome. Thank you very much for your patience. Apologize if there is something wrong with the online session, but I'm providing the consultancy service under Faculty of Medicine because I'm not anymore in EDEC, unfortunately. But I'm running the statistical clinic under RMC in the Faculty of Medicine. If you need, any consultation service, you can contact RMC Faculty of Medicine for booking a personal appointment.
Thank you, Doctor.
Okay, thank
You're
you.
welcome. Have a
Thank
good
you.
day.
Thank you so much,
Bye-bye.
Doctor.
You're welcome. You're welcome. Have a good day, everybody. Bye.
Thank
Okay,
you,
Adel.
Dr. Mahmood. Bye.
Bye.
Feedback.
Assalamu alaikum.
And give feedback.
Waalaikumsalam.
Alaikum assalam.